we are moving down by 5 units. We are moving to our right by 3 units. So let's say that's my 1, 2, 3. So this will be a point we'll take care of. Now, we need to check whether we have any asymptotes, right? So first of all, let us graph it. Oh, one more thing. We have a 4. We are multiplying the main function by 4. We started with 1 over x squared. We have moved to our right by 3 units. We have went down by 5 units, and this 4 means we are stretching the original graph by 4 units, right? So instead of, as I said, instead of 0, 0, now my new origin will be here at, sorry, at 3, negative 5. Okay, so I'll have a graph like this. So now my graph will look like this. Okay, I've just used, okay, that's what I was asking originally. I didn't realize above the fraction stretch. Well, once again, you can always write this as 4 times 1 over x squared, right? That means you are multiplying that original function. So that's how we can see that it's actually the same way we have seen before. Okay, so that's the graph. That's how the graph will look like. And if you see the options, option D looks like this, right? So this will be option D. Let me write it for you. Option D. Okay, we have just used the transformations. We don't really know what my new, although we have drawn the asymptote, but we don't know precisely whether we'll have a asymptote like that. But we have just used the transformation first to draw our graph. Now, by eyeballing this graph, we'll disclose this. Yeah, this is indeed our asymptote. This is our x-intercepts. If we'll have y-intercepts, we'll disclose that as well. But all of this we'll do by just eyeballing. Okay, so that's a good thing. We don't need to solve it algebraically. Anyway, so the next question is, what is the domain of the given function? Select the correct choice below, and if necessary, fill in the answer box to complete your choice. Okay, so first of all, domain means the values of x for which our function is defined. So by just eyeballing, don't look at the answer. I know the answer is given there, but just try to eyeball the graph here on your screen. Try to eyeball this and see the values of x for which this function or this fraction, you might say rational function, this is actually defined. Just eyeball it. The values of x I'm talking about, because domain is nothing but the values of x on the real number line. In other words, you might try to look for values of x where the function is not defined, and you can exclude those and say rest is our excuse me, rest is our domain. Okay, so your answer is right, but the way you have written, if you write like that, I'm not sure, you might not get a point for that, because I'm repeating myself. When you're writing using a set notation or an interval, whatever it's been asked, you need to write that in the exact format it recognizes, right? Because it's a computerized form, it might not understand if you write it in a different way. So the thing is, as you can see, first of all, it's not really defined at x equals 3, right? The graph from either side approaches to 3, x equals 3, but it never really touch or go past that. So apart from x equals 3, I can see the graph is defined everywhere. So we'll say that our domain is x such that x not equal 3. What's ARN? All real numbers. Okay, once again, uh, uh, cannot equal 3 doesn't really make any sense mathematically. I know, again, I know what you are trying to say, but a computer might not get that, right? Well, you can type that. Let me type it for you. No worries. X equals, you might type like that. Because this is not a mathematical platform. Anyway, as I said, I know what you're trying to say. So just make sure that you're writing it in the exact format. That's what I'm trying to point out. Anyway, so using the interval sign, yeah, of course, your answer is right. It will be from -infinity to 3 and from 3 to infinity. Okay, very good. Yeah. Okay, next we want to see the range. Now, this is crucial because often we talk about the domain, but very rarely we have talked about the range. But if you know the graph, if the graph is given, you can eyeball it, then it's really easy to see where your domain is and where is your range as well. So the range is, if you know the definition, the values, the defined values, of course, of y. That means if you look at the graph, you just need to see where your graph is going on, where your graph is taking you on either side, both upwards and downwards. You just need to check whether your graph can move to either side, or if it can't, where it stops, or how far can it go, what's the restriction and all that. But it's obviously on this direction, right? So again, without looking at the answer, can you see what is the range? -5 to infinity, or would you use, okay, so you have actually answered your own question. You can't really cross or touch -5. So what should you use? Because you can see the graph is not crossing that exactly. Yeah, you need to use -5 to infinity, brackets like this. Or if you want to write in a set notation, it will be y such that y is greater than -5. Because I can see that my graph is not going below this y equals -5 line. Okay. So next we have, what is or are the vertical asymptotes? Select the correct choice below, and if necessary, fill in the answer boxes to complete your choice. Okay, so what is your vertical asymptote? And again, as you have calculated the domain, you can see, or even from the graph, you can see your line is not really crossing, or rather your graph is not really crossing this line, x equals 3. So clearly it will be a vertical asymptote. So we'll say x equals 3 is our vertical asymptote, right? Okay, next is the horizontal asymptote. Again, as we have seen or rather calculated the range, we can see this graph is never really going beyond this. It has restricted itself to this line. So that means we'll say y equals -5 is our horizontal asymptote, right? The next question is whether we have an oblique asymptote. And as far as I can see in the graph, the answer is a big no, right? So clearly you can see, although I'm doing it really slow, you can actually finish this problem probably within 2 minutes. I don't mean that you need to do this in 2 minutes. Take your time, considering the fact you will have more than enough time to complete the test. If you can track your time, if you keep an eye on your time, you can spend more time on this. But again, if you know the concept, uh, it's really easy, especially to once you have problem A, it's easier to calculate the B, C, and D. B, C, D, E, and F, right? Excuse me. Okay, so that's problem 6, I believe. Is it? Yeah, that's problem 6. Next, let's see what was the problem in our list. Where is that? After 6, we have 7. Okay, let's see 7. No, I don't think 7 is. Yeah, I think I have said don't try 7, didn't I? Right, yeah. Okay. So let's see what's next. 10, 17. Or you want 8? Okay. So 8. Okay. Graph the following polynomial using the graphical tool. Okay. So first of all, let's write the function 2x cubed 3x squared plus 4x plus 6. Okay. And we want to graph it. So first of all, can you see how it will behave, which type or which function it will look like? Can you see? Right, y equals x cubed, because I can see this guy here. So all I'll try to do is factorize it if possible. So if I try to factorize it, let's see what happens. I'll try to see for the factors. If I plug in a -1, it will be -4, it will be -2, so it will be -6. We already have +6, so it will not really matter. So let's try a -2. -2, it will give us a -8. This will be -16. -16 and -8 will be -24. -2 squared will be +4. It will be 12. Plus 6, 18. No, it's not a real 0. That means I'm just looking for a real 0. Okay, I'm just looking for a real 0 for this. -2 doesn't work. Let's try. Okay, -1 doesn't work. -2 is too much. So the more I'm going to my left, it will be actually bigger. If I take a +1, it will be never 0. So I need to take something negative. Okay, so let's try a -12. So -12 cubed will be -1/8 times 2, 3 times 1/4, 4 times -12 plus 6. So this will be -1/4 plus 3/4 minus a half, another 2 plus 6. Okay. So if I add this, -1 plus 3, -8 plus 24. No, it doesn't work either. Okay, 1/4, 3/4, -2 plus 6. No, it won't work either. So what we can do, instead of spending too much time on factorization, because as far as I can see, it might require a bit of more time, which might be difficult, which might create difficulty for me to finish the test on time. So what I'll do, I'll go for the other way. I'll go for the x-intercept, I'll go for the y-intercept, I'll go for the turning points and all that, okay? So if I plug in, let's try y-intercept. If I plug in x equals 0, I can see all I'll have is 6. That means 0, 6 is my y-intercept, okay? What? The answer is given, right? What is the answer? Well, I think the answer they have given here is wrong, because I can see the y-intercept is at 0, -6. That's not possible. Simply, you can see if I plug in zeros here in place of x, I'll have a +6. There is no way I can have an y-intercept at 0, -6. As you can see on your right, it says, looks to me, the intercept is at y equals -6, right? Oh, you have -3 halves. Oh, okay, we'll see that later on. But first, can anyone check it for me? Is it only me who is seeing it at 0, -6, the y-intercept, right? It looks to me it's 0, -6, right? Can you see that? Just look at the graph. But it can't be possible. It's not possible, because as you can see, if you plug in a 0 in place of x, it should be in 0, 6, right? Okay, so I think you can ignore that solution. Yeah, that's a wrong solution. I'm sorry. That's been generated by MyMathLab, so it was not possible for me to check all the answers, so I apologize for that, but that is definitely a wrong answer. Anyway, so our y-intercept is at 0, 6, right? Okay, graphed it in Desmos, and you're right. Okay, thank you. Yeah. Okay, so if you're not said, or if you're not asked by the question to factorize, you don't need to factorize. If you want to factorize, that's all right. But again, as the question says, graph the following polynomial, you can always graph it using your own methods. You don't need to do a certain thing. Okay, that's Okay, just want to point out that you said we wouldn't have a poly to the third mainly for time purposes. Is it still true, or should we try the fast way you're showing? Okay, so once I finish this lecture, okay, due to the factoring, but if we can do it without, then it doesn't matter. Okay, so first of all, as far as I remember, I didn't really give you a problem uh, where you need to spend a whole lot of time or which is really complicated. But again, uh, what I'll do, I'll recheck the entire test, whether I have a problem like this where you have to deal with a polynomial uh, uh, of exponent more than 2. Okay, if it's more than 2, uh, I'll probably change it because I still have time to change that, but I don't think I have given you a question like that. Yeah, so definitely you will not required to factorize problems like this. Okay, you'll not be asked to do like this, but again, you can always graph it using these methods. But if I have any question of uh, degree 2 or more than 2, I'll change it and keep it to 2 or less. Okay, so don't worry. But as we have started this, we'll finish this problem. And we also want to know, I know you already have seen this, but we also want to know how to graph a polynomial of degree 3 or more. Okay, so that's our y-intercept. Our degree is 3. That says I'll have 2 turning points. Okay. Okay, and what else can we do? Let's see. We have x cubed and we'll multiply this by a 2. So this will stretch the graph 2 times than the original one. Okay. So what it gives me an idea. First of all, let me draw the graph for y equals x cubed. That's the graph of y equals x cubed. Okay, I definitely know it will have an intercept at y equals 6 instead of 0. So my graph, and of course I know I'll have 2 turning points. Now the next thing I need to know is where these turning points will be, right? So let's take a value. I know I'll have 3 because of this degree 3. I know I'll have 3 x-intercepts. 1 or 2 could be identical. I might not have 3 distinct intercepts, but I'll definitely have 3 values. 2 could be identical. Anyway, so instead of 1 intercept, I'll at least have I'll have 3, but it could be identical as I said. And as I said, I'll have 2 turning points. Okay. Now, as our 0 is 6, so what we'll do, we'll try these intervals and see where it takes us, right? We'll take value from each of these 2 and see where does our graph take us. Okay, so if I take a value, let's say 0 from this, my functional value will be, if I plug in a 0, it will be 6, right? I already know that, so let's avoid that. Let's plug in 1 instead, or -1. Yeah, -1 will be a good choice. The degree represents how many intercepts we'll have, correct? Well, the main idea is whatever your polynomial is, xn plus dot dot dot, your degree means you'll have that number of solutions for x. And for graphical representations, yeah, that also mean we'll have that many intercepts. But yeah, you need to have this in mind, that you might have identical solution. Okay, so you might not see it having the same number of intercepts, but you'll definitely have this number of values for x. Okay, if you solve it. Okay, so if I take a -1, -1, I think I've tried it, right? Yeah, -1 will give us -2, +3, that will be +1, -4, that will be -3, +6 will be 3. Did I do it wrong? 2, and it will be 4, so 6, 6 and 6, yeah, I think it's 3. So I'll have -1 and 3 somewhere here. Okay, and let's take a value from this, let's say 7, and if I plug in 7 here, 7 cubed, as you can clearly understand, 7 cubed will be a big number, which is 343, and if you multiply this by 2, it's already 686. So you don't even need to calculate all of this, it will be a huge number, right? So let's say that's my 6, that's my 7, so it will be somewhere up here, right? It will be a huge number. And as you are going to your left from here, as you can see, the value is slowly and slowly decreasing, right? Because all of these are positive, so you will have a value which is going downwards. And for -1 we have this. So looks to me for 0 it's 6, for 1, for +1, how much is that? 10, 13, and it will be plus to 15. So the graph might look like this. Okay, this should look like this, but again, it's not the precise graph, simply because we don't really have the x-intercept. Okay, and what I can do for you is I can actually give you the x-intercepts instead. So let me do it for you. Just give me a second. Yeah, I'll actually do that, because I already know, as I think it was John, you right, that x equals -3/2 will do. So I can actually factorize it. Let's do that. Let's do this here. So f of x will be 2x cubed, 3x squared, 4x, plus 6. And if I plug in a -3/2, 2 times -3/2 cubed, 3 times -3/2 squared, -3/2 plus 6. So it will be 2, it will be negative, it will be 27 over 8, 3 times 9 over 4, it will be a negative uh, 4 times 3 halves plus 6. So if we calculate it, it will be negative 27 over 4 plus 27 over 4. So it will be cancelled. It will be 2, negative 6 plus 6. Yeah, good job. So that means it's a real 0. So as you know, x minus the real 0 is a factor for your function. So it means x plus 3 halves is a factor for your function. What we can do, we can write it in this format: 2x plus 3 by 2, and we can keep this half outside. Instead, we can write like this, and as this is also a factorized form, we can clearly say 2x plus 3 is also a factor for f. Now this will make our life easier. So the first line was 2x cubed plus 3x squared plus 4x plus 6. If you remember, we'll start from here, 2x plus 3. So I'm taking 2x plus from this. So I'll still have x squared, right? Because now this will give me 2x cubed. And if I multiply this by 3, I'll have a 3x squared, which is this one. That's very good. Next, we'll start with 2x plus 3. And we have 4x here. I've taken 2x out of it. I still have a 2. And 2 times 3. Sorry, first of all, I need to write 4x here for this 2. And if I multiply 2 by 3, I'll have a 6. So fortunately, it has taken us less time to factorize. So I can now factor out 2x plus 3 from each of these terms. I can factor out 2x plus 3. From the first term, I'll still have x squared. From the second term, I'll have a 2. Okay. So this is your most factorized form. And now you can see why does this graph will look like this, okay? Or it will be similar to this, simply because, first of all, we'll have an intercept. If we solve it for x equals negative 3 halves, which is somewhere here, as I said, it is somewhere here, okay? Or what was this point? I think it was negative 1, was it? Oh, sorry. So it will be somewhere here, okay? Negative 3 halves, slightly more than 1. Although, as I said, it's not the precise graph. So that's one of the intercepts. And as I said, you'll have 3 different values because you had x cubed to begin with. But from this, you can see x squared plus 2 equals 0. If you solve it, you get x squared equals negative 2. Is it possible for real numbers? And the answer is no. So as I said, this doesn't guarantee you that you will have 3 x-intercepts. You need to check that. And fortunately, on this occasion, you can see instead of having 3 or even 2, we'll have only 1 x-intercept. Okay, so this graph, as I said, will look pretty much like this. Not exactly like this, maybe, but it will look pretty much like this. It will resemble. As you know the x-intercept, you know the y-intercept. I think that's what you need. Okay, and let me quickly show the exact graph to you. As I've spent time on this, I'd like to take 1 or 2 minutes more to show you the exact graph. Okay, 2 times x cubed, 3 times x squared, plus 4 times x, plus 6. Okay, and oops, sorry, it's 2 times x cubed. Okay, yeah, let me share the picture with you. Okay, I'm sending this to my iPad. Soon you will be able to see that. Here you go. As you can see, the graph looks like this. Okay, sorry. Okay, I've used my mobile. I have an app called Symbol app. That's very easy to use, and it gives you the graph, the intercepts, and all that. And as you can see, let me use this picture real quick. Okay, I can use this picture here. Let's use that. So from the photo library, I'm going to use this. And now I can edit this. As you can see, I have an intercept as each squared is 2. As you can see, this is 10. And 1, 2, 3, 4, 5 squares gives you 10. That means each square is 2. And that means it's definitely 0, 6, right? And as this is 5, 1, 2, 3, 4, 5, that means each of these is 1. It's exactly between 1 and 2, so that gives us an idea that it's actually 3 halves. That means 1.5, right? Are you guys with me? Any question from this? Again, it's pretty obvious that I'm not going to give you a problem which will require you to work on that for 10 to 15 minutes. That's absurd. I'm not going to do that. So I'll recheck the problems from the test. I really think that I have avoided problems like this, but I'll recheck that. Anyway, what's next? Next is problem 10. Okay, problem 10. Okay, let's start. Unless someone wants to do 9. Is there anyone who wants me to do 9? I guess 9 is pretty easy. You can actually do that because you are moving that upwards by 1 unit. X plus 1, the quantity to the fifth means you are moving to a left by 1 unit. You are multiplying that by 5 means you are stretching that 5 times than the original graph. So that should be pretty easy. So I think you can start problem 10 instead. Okay. Okay, problem 10. F of x equals x cubed minus 5x squared minus 61x minus 51. 55, right? Yeah. Okay, so the factors of 55 will be plus minus 1, plus minus 11, plus minus 5, right? Well, the theorem is basically the same as we have said vocally. That means you just need to find a value which makes your function 0, and that's uh, uh, that will actually give you the factor as well. Okay. Now, can you see any value which will make your function 0? Can you see that? Can you find any value which will, of course, from the, as I said, you need to find that from the factors of the constant term. Fortunately, for 55, there are only a few factors. So can you see any value which will make your function 0? No one? Okay, so as we don't have too much values, we can actually check. That's quite easy. So if we plug in, let's say, okay, so it will be, it's already negative something, right? Which is really big. So your intuition should say, oops, sorry. Your intuition should say, if you take something negative, this will give you something positive, which might help. So let's try a negative 1 first. So it will be negative 1, it will be negative 5, it will be positive 61, it will be negative 55. So looks like, yep, it will give you a 0. So negative 1 is definitely one of those. Let's try negative 5 as well. So it will be negative 125. It will be negative 125. It will be positive 5 times 61 will be 305, I believe. Is it? 5 times 60 is 300. Yeah, it should be 305. Negative 55. Oops, sorry. And it's negative 250 minus 55 is negative 305. Yeah, that's right. It will also give you a real 0. As you can see, just by using your intuition, you can find out the values. Okay. My intuition clearly gives me an idea that if I take something negative, as I already have a negative value here, which is really big, if I take something negative, this will give me this will help me to get the real 0. But for the bigger value, this might not be the case, because if you take negative 11, this will be positive 61 times 11, and this will be difficult to nullify, okay, to make it 0. So what we'll do, instead I'll try a positive 11. Let's see what happens. So 11 cubed minus 5 times 11 squared minus 61 times 11 and minus 55. And 11 times 11 is, I guess, 11 times 11 will be 1331 minus 5 times 121 will be 605 minus 61 times 11 will be 671 minus 55. So 671, 55, and 605. Yeah, these three will combinedly give me 1331. So that's a real zero as well. Well, this is not a good way. This is the way, perhaps. You need to just look at the factors of the constant term, not the last term. The last term is kind of vague, you know, because I can always rewrite this as, let's say, negative 55 minus 5x squared minus 61x minus x cubed or plus x cubed. So last term is not the right choice of word. Instead, you need to look for the constant term. And if you know the, okay, all right, I was confused myself in how we were choosing the numbers to find zero. Yeah, no problem. So the thing is, you need to find the factors of the constant term. Again, I'm repeating, that might not be the last term, because you can always rewrite this and rearrange this, you know. You can use different orientation. Yeah, I know what you mean. I'm just trying to make it clear. So you need to look at the constant term and check the factors of that. Of course, plus minus. You can always try fractions as well, but for bigger values like this, generally the normal factors will do. And the less factors you have, the less time it will take to find out all the zeros. Okay. And now the next part is pretty easy, because we know x minus the real zero is a factor. Sorry, is a factor. So our real zeros are -1, -5, and 11. So our factors will be x plus 1, x plus 5, and x minus 11. This will be our factors. Okay. Next we have problem 17. Okay, let's try that. Problem 17. Problem 17, what is that? Okay. Oh, it's a big question. So it will take a lot of time. If I simplify each thing. Anyway, let's start. Number 17. It's a very important question, although, because in that single question, you can actually use all the concepts, I guess probably from 4.1 to 4.3, you can use all the concepts in a single problem. So that's a good question to answer. Okay, so our function is x squared plus 2x minus 48 over x plus 4. Okay, and the first problem is first write the given function as a single rational expression, then factor the numerator and denominator, select the correct choice, and if necessary, fill in the answer box to complete your choice. Okay, so first of all, can you factorize it? If yes, then you will say, you will click the option that this function is already in factored form. But the question is it factorized? Can you factorize it anymore? It doesn't mean that all the polynomial all polynomials can be factorized. There are polynomials which you can't factorize as well. So you actually need to check. Okay. And sorry, my laptop is making the sound. Anyway, so for that, once again, we'll try and see the factors of 48, and the factors are plus minus 1, plus minus 2, plus minus 3, looks to me 4 as well, plus minus 6, plus minus 8, plus minus 12, plus minus, if we divide it by 3, $16, plus minus 24, and plus minus 48. So these are the factors. As you can see, lots of factors you have here. But we need to find, as this is a smaller polynomial, it will be easier to factorize. Okay. What you can do instead is this, right? You can use this. So the reason I showed this, because for 55 we have seen that we have less number of factors, but that might not be the case. That's why I showed you these factors. But as it's a degree of 2, you can use this method. So your sum will be 2 and your product will be negative 48, right? So you are looking for two values, two numbers whose sum will give you 2 and whose product will give you 48. So it will be 6 and negative, it should be positive 8 and negative 6. Simply because your sum is positive, so the bigger value will be positive. Okay, so we can clearly write x minus 6, x plus 8 over x plus 4. This will be your answer for A. Any question from this? Okay, next, what is the domain of this function? Okay, so that's your fraction or the rational function, and you need to find the domain of this. Can you eyeball it? Can you eyeball, excuse me, because for rational functions, as I said yesterday, you will be asked to find the domain, probably more than once. Yeah, very good. X will not be 4. Apart from that, everything else will be your domain, because if x is negative 4, as you can see, if I set this to 0, I'll get x equals negative 4. So if x is negative 4, your denominator will be 0. That's what we don't want. That means apart from x equals negative 4, everything else will be our domain. Okay. Okay. Next, write the function in the lowest term. So can you reduce it anymore? Because if you can't, then this is the lowest term. But if you can, then you need to reduce it, because when the question says write this in the lowest term, you need to reduce that as much as possible. Can you reduce it more? Let me ask randomly from the participants. Dulcie, can you hear me? Again, I apologize if I pronounce your name wrong. Whenever you unmute yourself or you're going to answer, correct me if I am doing it wrong, okay? So Dulcie, can you hear me? Okay, looks like she's not. David, are you here? So my question is, can you reduce this fraction anymore? Is it in the lowest term? Is this function in its lowest format? That means you can't reduce it anymore. David, are you there? That's quite awkward. Even yesterday I saw, I can see the participants out of 34. Today 14 of you are here, but if I call you by name, only 5 or 6 will answer. So I wonder what's going on there. So what I'll do from tomorrow, I'll give you points for participation. And if I call you by name, you don't answer, I might penalize you. I might, I'm not saying, because I'm not that cruel, but that's really disheartening because it looks like some of you have just logged in to show that you are attending the class, but you are not actually there. So that's not a good sight for as an instructor from my point of view. If you have other work, you can always avoid the class because I'll show the work, I'll share the files. But if you join the class, you're expected to stay in the class, okay? It's quite disturbing to see that you are actually, the participant list shows that you are here, but you are actually not. Okay, so, okay, let's do this from tomorrow because this is not what we expect. I'm a student as well, and I can see how irritating it could be for an instructor. Anyway, so yeah. Oh, that's a good point. Yeah, we don't have a class tomorrow. Yeah, so maybe what I'll do, I'll make an announcement probably, because if I do this without making an announcement, that will be cruel as well. And you can see I'm trying to be really student friendly. I'm trying to see everything from your point of view because I'm a student as well, as I've said. I'm not a typical instructor. So what I'll do, I'll make an announcement. Probably I'll start that from the next week. Are you guys okay with that? I know I can see 7 or 8 of you who answers every day. I really like that because you participate, you interact with me, you ask questions. That's really good. Anyway, yeah, so we'll start from next week. Okay, so as I have the answer already, definitely it's already in the lowest term because you can't really reduce it anymore, right? You can't really reduce it anymore, which makes the function in its, or which keeps it in the lowest term. Okay, next, let's see what we have. Find the intercepts. Very good. That's a very interesting thing. We always look for the intercepts. So for y-intercept, we'll just plug in 0, right? So it will be 0 minus 6, 0 plus 8, 0 plus 4. So it will be, I think it will be negative 12, right? For the, as I'm plugging in x equals 0, my y-intercept will be negative 12. Okay, now we want to find the x-intercept as well. So we'll set this to 0. Now we'll solve it. What is the function again? X minus 6, x plus 8, and x plus 4. This is 0. Our denominator can't be 0. So we'll have x minus 6 times x plus 8 equals 0. If we solve it, we'll get x equals 6 and negative 8. So this will be your x-intercept. Okay. Excuse me. Okay. Next, determine the behavior of the graph at any x-intercept. Select the correct choice, and if necessary, do this and this. Okay. So first of all, to determine the behavior, we just want to see the real zeros, that means these guys, and look at their multiplicity. Okay, if you remember, let me quickly take you to the flashback. If you have an even multiplicity, that means your graph will touch that point, but it will not cross it. And for the odd multiplicity, your function will actually cross the x-axis at those points. So as you can see, we have multiplicity of 1. So definitely the graph will go past or cross the x-axis at x equals 6 and x equals negative 8. Does it make sense? Very good. Okay, let's try the next one. As you can see, only the hardest job, probably if there is any, was to find this, which was not really time consuming either, because it's a degree of 2. So rest, you can see, you can actually calculate it within a couple of seconds. So again, your first job is to focus on the problem and each word, because you need to take care of each word. One additional word or one less word in the question might change the entire answer, might change the entire scenario. So if you are keeping an eye on that, you can see the question will be, I'll not say really easy, but it will be easy, definitely, as you can see. Okay. Okay, next, where is that? Okay, of course, the asymptote. So the vertical asymptote, as we know, for vertical asymptote, we just need to set our denominator to 0. Oh, sorry, my handwriting is getting poor and poor. I apologize for that. X equals negative 4. So if I set my denominator to 0, if I solve it for x, I'll get my vertical asymptote, right? So x equals negative 4 will be my vertical asymptote. Okay, next, we need to determine the behavior of the graph on either side of any vertical asymptote. Okay, again, we need to look at the real zero, which is of course this. And this real zero, once again, has a multiplicity of 1, right? And if you remember, if we have an odd multiplicity, your graph will approach to positive infinity from one side and negative infinity from the other side. You don't yet know from which side it will work, but definitely it will be on positive infinity on one side and negative infinity on the other. Okay, so if we have a graph like this, x equals negative 4 should be somewhere here. That's my asymptote. All I know that if the graph moves or approaches to positive infinity in one side, the other side it will approach to negative infinity. Okay, if you have odd multiplicity for that real zero, from where you are calculating the vertical asymptote. Okay. Next, determine the horizontal asymptote. Okay, let's do that. So for horizontal asymptote, if you remember, the idea is to look for the values which makes your or rather where your graph can't really cross, right? So where is that? Where is the main function? Oh, here it is. So by eyeballing, can you see anything? Can you see any horizontal asymptote you can find out from this? Okay, let's go back to the main problem. I mean, the original format. By just eyeballing, can you see any horizontal asymptote? You know the shortcuts, right? Who can quickly tell me the answer? Don't look at the answer on the PDF file. Okay, so first of all, we need to check at the degree, right? If you remember, the degree of the numerator is 2, the degree of the denominator is 1. That means it's n greater than m, right? And if n greater than m, then we can straight away say, hey, we don't have any horizontal asymptote. Yeah, very good. Yeah, we don't have any horizontal asymptote. As you can see, you can just eyeball it, okay? Even from this format. If the question is in this format, you can still eyeball it, right? Because you have 2 x's here as a product. So definitely your degree for the numerator will be 2. Even if you have this format, you can also eyeball it. So you won't have any horizontal asymptote. Okay. Next, we need to look for the oblique asymptote if we have any. Let's see. Once again, we'll go back to our problem, which is this. You know that we'll have oblique asymptotes if and only if m is just 1 more than m, right? Yeah, very good. So on this occasion, is it true? Can you see that? And the answer is yes, because 2 is of course just one more than 1, right? So definitely it's true. So we'll have an oblique asymptote. Okay, and if you remember, for calculating oblique asymptotes, we need to go to, or rather we need to use this typical division method, x squared plus 2x minus 48 plus 2x minus 48. Okay, and you have x plus 4 here, right? Am I doing it wrong? No, x plus 4, yeah. Okay, so it will be x here because x times x will give me x squared, and x times 4 will give me a 4x. So as I'll subtract this, the signs will get altered. So this will get perished. All I'll have is a negative 2x, right? And a minus 48 will come down. The next term always comes down, right? Okay, now I'm looking for negative 2x. I have x here. So if I just try with minus 2, you can see that negative 2 times x will give me my desired result, okay? And 4 times negative 2, it will give me negative 8. So once again, the signs will get altered. This will be plus, this will be plus. So this will get perished. This will nullify each other, and we'll have a negative 40 here. So if you have this format, the clear shortcut is, the quotient is your oblique asymptote, right? Is the remainder written as, no, I'll show that format. So you can actually rewrite this function as x minus 2 plus the remainder over the divisor. That means it's actually x plus 2 minus 40 over x plus 4. Okay, that's the way to write it. But for the oblique asymptote, a shortcut is the quotient is your oblique asymptote. So your answer will be y equals, x minus 2. Okay, does it make sense? Okay, it's a long question. What's next? Determine points, if any, at which the graph of f intersects the horizontal or oblique asymptote. If one exists, select the correct choice below and do blah, blah, blah. Okay, so if you remember, your graph can actually cross the horizontal or the oblique asymptote in a certain region. It's not true for the vertical one though. Your vertical asymptote will be always untouchable. Your graph will never cross it. But the horizontal asymptote, yeah, for the oblique asymptote, of course, your graph for a certain interval, it can cross, but for other intervals, it will be working as an asymptote as well. So let's see if our function can cross this x minus 2. And how can we calculate that? Anyone? All we are looking for, okay, yeah, all we are looking for, is there any point, that's our x minus 2 asymptote, that's our oblique asymptote, x minus 2, y equals x minus 2, okay, that's negative 2. So our question is there any point where your graph will actually cross this line? Is there any point like that? Because you know your function, your graph could actually cross your oblique or horizontal asymptotes in a certain region. It's not true for vertical though, as I said. So now the question is there a point where you can see your graph will do or behave like this? It will intersect your oblique asymptote. Is there any point like that? The question is, how can we calculate that? Excuse me. What type of graph do you have? Well, the next question is, using the information you have, you need to find, or rather choose the graph for this function. But as of now, we don't really know how the graph will look like. That means you need to solve it algebraically. Okay, you need to find it algebraically. And the answer is, well, for any intersecting point, the basic idea is, if two functions intersect each other at any point, at that intersecting point, those two functions will be equal. If you remember, we have done a problem like this. I guess it was yesterday. Yeah, yesterday we did a problem like this. So at the intersecting points, if we have more than one, those two function or those two curves, those two polynomials, whatever you have, will be equal to each other. So that means if my function, which is x, what was the function again? I hate this to scroll down. X minus 6, x plus 8. Let me use a bigger space. X minus 6, x plus 8 over x plus 4. If you have an intersecting point, this will be equal to the oblique asymptote, which is x minus 2. Okay. Now, if you solve it for x, you will get different values of x where this will intersect each other. Now, the question could be, is it possible to find a value from this? Can we solve it? That's it. So let's give it a try. X minus 6, x plus 8. I'll just cross multiply it here. So x minus 2, x plus 4. So I just expand this, x squared minus 6x plus 8x minus 48. And x squared minus 2x plus 4x and minus 8. So this will cancel each other. This will be positive 2x, this will be positive 2x, so this will cancel each other. So we can see we have negative 48 equals negative 8. Is it possible? And the answer is no. So there is no intersecting point. There is no point where the graph will intersect or cross this oblique asymptote. Okay, so the vertical and the oblique intersect each other, which makes it impossible to cross the two asymptotes. Yeah, that's a good point as well. The vertical and the oblique asymptote will actually cross each other, right? Yeah, but it could be somewhere else, right? It could be because your vertical asymptote will intersect your oblique asymptote here, but your function could still intersect your oblique asymptote here. So we need to check, okay? Anyway, so these are the informations we have. Now we want to graph it. So first of all, I'll quickly see what are the informations in our hand. So the y-intercept is at 0, negative 12. The x-intercepts are 6, negative 8. We have a vertical asymptote at x equals negative 4. We have an oblique asymptote x minus 2. And it will not, the graph will not cross that. So first of all, x equals, what was the vertical asymptote again? X equals negative 4. So x equals negative 4, let's say that's here. So we'll have an asymptote here, okay? And we have an oblique asymptote which will behave like this. Oh, I showed it actually the other way. It's actually intersecting it here. So your graph could intersect the oblique asymptote somewhere here. Anyway, that's the idea. So that's your asymptotes. Next, we know the graph will have an y-intercept at 0, -12, and